Hello everybody and welcome back to another tutorial video. In this tutorial we'll be covering how to use the new empty cavity feature in ACCS RTM. Now to showcase this new feature I'll be modeling an example from a paper, and the paper I'll link in the description below. This archive project will also be linked below, and that includes the geometry that will be used in this video. Now if we take a look at the model from the paper, we'll see a model which is of length 3e minus 4 meters and a thickness of 5e minus 5 meters. And then it's split up into 3 equally sized domains. These are the fluid domain, the first porous domain, and the second porous domain. Now the porous domains will be modeled similar to how you would use ACCS RTM before, with material fabrics with permeabilities, but the fluid domain will be modeled using an empty cavity material. You will also notice that the permeabilities they provide come with porosity, and we'll have to divide the permeabilities by the porosities in order to get the correct permeabilities to use in ACCS RTM. Now let's define the engineering data. And when you open up the engineering data module, you'll see that I've already created 4 different materials. For the porous domains 1 and 2, I've already calculated the permeabilities to be used in ACCS RTM. You'll see these below. And you'll also see that I've defined a resin with constant viscosity, and the viscosity value is 1e to the minus 6 Pascal seconds. Now what we'll have to do is define the fluid domain's empty cavity. Now to find this material property, you can scroll all the way down to the ACCS RTM fabric section of the toolbox and double click empty cavity, and you'll see that you will need to define an equivalent thickness. Now if we refer back to the screenshot, you can see that the thickness of the model is 1e to the minus 5 meters. Sorry, 5e to the minus 5 meters. So we'll enter that value here below, 5e to the minus 5. Then that's it for the fluid domain material property. That's all you need to add. Now let's head back to the project screen and update our model. And wait for that to be finished. Looks like it's done. And then we just double click on the model to enter mechanical. Now when you open mechanical, you'll be greeted with the model, and you can see that the model is split into 3 sections. These 3 sections will be the fluid domain, the first porous domain, and the second porous domain. So what we need to do is first define our thicknesses for each of these domains, which will be 5e minus 5 for all of them. Once you've done that, we'll assign the materials. So S3 should be the second porous domain, S2 should be the first porous domain, and then finally S1 should be the fluid domain. Now after this, you want to generate your mesh, and then insert a node merge group. This is to ensure all of the bodies are connected, and we can set the tolerance to be 1e minus 5, then click generate. And you can see here 14 nodes were merged. After that, you want to create a pressure inlet and an outlet, and you want to assign the pressure inlet as the left hand side and set the pressure to 0.06. Now if you go back to the model, you'll notice that only a velocity inlet is set rather than a pressure one. However, we take the pressure value from later on in the paper, and then we'll see in the results whether or not our velocity matches the inlet velocity. Now we want to set our outlet to the right hand side edge, and then our loads are defined. Now let's head to analysis settings and change our resin to the RTM resin, and then set the number of cores used to 0 to use the maximal number of cores that your computer has. Now let's insert a couple of results. One fill result, one pressure result, and then of course the x velocity result. And let's solve. Now that the model has solved, we can look at the fill progression, and you can see that the flow front is quite linear. And then if we head to the velocity x result, we can see that we get a value of 0.0012126. If we head back to our screenshot, this value is very similar to the inlet velocity from the paper. If you also want to see the pressure distribution, you can see it from the pressure result here. That's it for today's video. Thank you for watching.